Alrighty, let's go ahead and get started. Good afternoon and welcome everyone to our fifth bootcamp session of the Run on Less Electric Depot series. For those of you joining us for the first time, my name is Rachel Ellenberger and I am the Industry Engagement Manager for the North American Council for Freight Efficiency. Next slide, please. And for those of you joining us as I mentioned before, this is our fifth of 10 sessions that NACFE and RMI are hosting throughout the summer, talking about all of the considerations, all of the requirements of fleet depot electrification. So as of this session, we are officially halfway through. And for those of you planning to join us on our full journey here are the dates of the upcoming sessions. This schedule of sessions is also available online at runonless.com. And our next session will take place on July 11th. Our moderator, Ari Khan, who you will remember from our first session on best practices for utility fleet relationships, will host his panel of experts to discuss resiliency and availability. Next slide, please. So I'd now like to turn it over to our Executive Director, Mike Roth, who is out in the field with some exciting updates from the run. Mike.
Thanks, Rachel, and hello, everybody. I'm really excited. I'm actually going to miss this boot camp session, but I'll watch it later on in the week because I'm at Watt EV in Long Beach Port. We're here doing filming of interviews and talking to the team here that have put in place the operation here. They've run a Nikola Tre battery electric trucks all throughout Southern California. This is the one of 4 locations Watt EV is launching. On the screen there, you can see the third and the fourth visit that we made in the last couple of weeks. So on the right is OK Produce. They're in Fresno. What a fantastic organization deploying electric trucks. There we focused in on the 3 orange EV trucks they have in operation, as well as 10 e-Cascadias. With more coming, and they were being charged and operating out of their Fresno distribution center. Can't wait to give you information and video on all these sites, but that was the third visit. And then the fourth one was at Performance Team Logistics, operating out of Commerce, California, in a sister location a few miles away at Santa Fe Springs. There they're running Volvos and have been for some time. Both Gen 1 and Gen 2 with a 4 battery pack and a 6 battery pack. Really exciting there as well. So, you know, some numbers for you at those 4 locations. We've conducted 50 formal interviews with, truck drivers, with the truck manufacturers, the fleets, many other folks that helped create these depots and making them successful. So very exciting. In August, we'll be publishing data and information on each of these sites, highlighting a profile video that we'll post throughout the month of August. So it's fun being out here talking to them. I wish you all could be here, as they say, because we're getting incredibly good information and be able to share it with you throughout August and September. Back to you, Rachel.
Awesome. Thanks, Mike. So a few quick bits of housekeeping before we get started. If we could go to the next slide, please. So first, I would like to thank this session sponsor. We're really excited about the sponsor for this session because Geotab is the official data partner for Run on Less Electric Depot. We are utilizing their systems to provide data to our dashboard, which will be live during the run. Thank you so much for your contributions in support of our programs. We are really appreciative of this partnership. Next slide, please. So as a reminder, be sure to complete today's quiz. This quiz will become available during the session, and this is going to be your opportunity to test your knowledge from the session. So upon completion of today's quiz, you will graduate from your novice badge to your depot proficient badge on your way up to the expert badge. The expert badge will become available after 10 successful quiz completions. So be sure to go back to the landing page for this session on runonless.com. You'll see that the button that was used to register for the session will now be available to take the quiz. And also a reminder that the materials and the quizzes from our last sessions are still available. If you didn't get the chance to watch the session or take any of the quizzes, they are all online along with the recordings, the slides, additional resources provided by our speakers, etc. So be sure to go back and review if you're interested. Next slide, please. Again, a reminder that this session is being recorded and will be available online later this week. If you didn't get the chance to submit a question on the registration form and would like to do so today, please use your Q&A controls in the upper right-hand corner of your screen. During this session, I will be elevating the questions that we received to our speakers. And for those that we don't get to, we are covered that we're not going to get to in this session or that we're not going to be covering in this session. We are collecting them to build out future content. So if there's something that you're curious about, be sure to send it in today. And finally, if you run into any technical issues, please reach out to Stefan Babcock. His email is on the screen. He is our technical support at GNA, and he will help troubleshoot. Next slide, please. And with that, let's go ahead and get started. I would like to introduce our moderator, Rick Mihelic, who you will remember from session 3 on electric truck developments. Rick is the Director of Emerging Technologies with NACFE and will be leading the discussion today. Rick.
Thanks a lot, Retro. The subject of range is always going to be a question for battery electric vehicles. So what we've done today is assembled an excellent panel of speakers. I'll go through that in a minute, but just a little reminder, if you have questions, fill them into the chat in the Q&A section. And if you are looking into attending the future sessions, please go to the Run on Less website and register for those as well. Now let me get to our panelists. We have Andrew Kotz, Senior Research Engineer from NREL. I've worked with Andrew on a couple papers in the past. He has got an excellent background in actual tracking of trucks and transport. And then we have Andres Camel, who's the Vice President of Alternative Drivetrains and Trading. Andres has an excellent background and is actually a physics major. We've got John Kress, who's Director of Advanced Electrification Technologies at Cummins, who's another deeply experienced person with respect to this topic area. And then Jason Sheik, who's Senior Director of Product Marketing and Strategy at Hyliion. So I'm not going to waste your time. Let's get into letting the panelists do their presentations. Each of them will have about 7 minutes to go through their slides, and then we will have Q&A at the end of the last panelist. With that, I'll start off with Andrew.
Great. Thanks, Rick, and thanks for the great introduction. So Rick asked me to sort of talk about some of the, basically some of the technologies that we've seen and some of the technologies we've discussed as part of our role at the National Renewable Energy Lab. So if you could go to the next slide. Just a quick background, my team is the Commercial Vehicle Technologies team, and we work to test new technologies and understand how we can rapidly advance those into the field and how the Department of Energy can help support that effort. So we're a Department of Energy national lab, and as such, our role is kind of a non-biased third-party role where we look at these technologies, understand where they fit in. We have another team within our group that looks at the EV grid integration, and they're actually part of the CharIN community and helped with the new megawatt charging standard. So they do a lot of looking at how do we help get these vehicles into the field and what does it look like when we connect them to the grid. If you go to the next slide. So one of the key tools in sort of our flagship product is the Fleet DNA database. And this was started in 2002, but what this really is a database of advanced technologies that are operating in the field. So we'll go and install some of the data loggers that you see in the top left on conventional vehicles along with a new technology and understand how we can extrapolate that technology to the broader vehicle population within the United States and abroad. And then one of the sort of key uses for that is trying to, and I apologize, I reuse this slide, but there's a red dot on it that you should ignore. That's not me. One of the key uses of this technology, or sorry, this tool, is to really understand how we can advance these technologies. And typically this is 1 Hertz CAN data, And then we use this data to help make insights, publish on it, while still keeping some of our partners, technology and IP confidential so that we can, help advance the industry. If you could go to the next slide. So one of the recent projects that we looked at, and that really kind of has an opportunity for some of the different unique battery and range extending technologies, is yard tractors. So we were working with the Port of New York and New Jersey to understand, what is the electrification potential of these yard tractors. And so we looked at 3 different terminals, and 2 of those terminals had decent electrification potential, but one of them had a very challenging time to electrify. So that was one that had a 3-shift operation of these trucks. They had about 2 hours of downtime per day. And you can see on the plot on the bottom left, which is data taken from the vehicle's J1939 CAN network, as well as our own logger and GPS, that shows that these vehicles, were operating up to, 24 hours at a time. And a lot of this is due to, when ships come in, they need to just be ready to unload those ships so that, they can get that ship out and keep the merchandise moving. And so this was, one of the terminals that really had a challenging time looking at electrification. And so, some of the options that we looked at exploring were increasing the battery size, reducing the charging time, and then adding vehicles to the fleet. The increase in battery size can be challenging because of packaging issues and cost. Adding vehicles is another thing that just adds costs, and the terminals have very limited space. So the key for this one was really looking at reducing charging time. So if you can go to the next slide. So one of the areas that we looked at was trying to identify a common lane for these vehicles to be in. And with the way that this operation works, these vehicles typically come underneath these cranes in the bottom right-hand corner. They'll sit there for a little bit, queue until a container is loaded, and then go and place that container or drive that container to its place within the stack. And so on the top right-hand corner, you can see the heat map where there's a heavy presence or a lot of scatter right around the dockside. And then you'll see the different lanes that the trucks go in. And so, this was identified as an opportunity where you might be able to have wireless or semi-dynamic wireless charging as an option for, short, high-powered charging events that they could then go and drive to the stack, come back, and charge. And so that was one of the suggestions to the client on ways that we could extend the range of these batteries. And to kind of put numbers to that, we did a sort of trade-off of a battery size and a charge rate analysis, which are in the bottom left-hand corner. And this was done using a electric vehicle model that we developed. And each point on this plot is a different battery size and charge rate combination that was tested to see if there were any SOC or state of charge violations where the battery went below 0% state of charge. So anyways, just the main takeaway from this is that when we took it from 50-minute stop time to 10-minute charging when there's 10-minute stop times or less, we saw a significant improvement in electrification potential, giving credence to the idea that this could be a way to electrify this fleet without increasing the battery size or increasing the charge rate. If you could go to the next slide. This is a similar analysis that we did for drayage applications, also out of the Port of New York and New Jersey on the left-hand side, where we saw, taking advantage of some of that opportunity charging. So if these vehicles were able to charge at stops of 10 minutes or greater, when, say, charging becomes ubiquitous or wireless charging becomes a part of these vehicles, we saw an increase in charge potential from 20% to about 40%, meaning that 40% of the observed fleets could potentially be electrified. However, charging like that is not ubiquitous. So, one of the other options that we look at or try and look at when looking at the data for different fleets that we analyze is hydrogen. And so one of the recent studies, and the report is actually coming out soon, was in the Port of LA under the Zero and Near Zero Freight Facilities Shore to Store project. We looked at hydrogen trucks as an option, and these were in service for about a year and had a 300-mile range and 10-minute refueling. So that's one other option. Happy to talk about it later, but I'll go to the next slide. And actually, I think I'm getting close to the end of my time, so I'll just say that, you know, one of the way we look at using the data is looking at the hotspots of frequent stop times for conventional fleets, and those are potential opportunities for where we can place charging. And in this particular study, we were seeing these 1 to 2 hour stop times at loading docks. And so that was another opportunity that we could say to the client, say, if you're looking to electrify, maybe talk with some of your customers about getting chargers within their loading docks to help you extend the range of your vehicles. So with that, I will pass it off to Andreas. And I think there's one more slide just for reference, but we can go on to the Andreas presentation.
Thank you, Andrew, for handing this over. So let's jump right into this. Maybe as a starting point from our perspective, this is more coming in from a techno-economic perspective of things and a bit more midterm, less right now, 2023. So we are talking more about the line haul potential from a battery electric vehicle perspective and what it takes to extend range in different ways to actually get us there. A brief starting point on the first slide would be to just talk about who we are from a Traton/Navistar perspective. Traton Group is a globally operating truck manufacturer group with our brands Navistar, best known for the international trucks, the IC bus, etc., and our European brands Scania MAN and a brand in Latin America as well, Volkswagen Truck and Bus. We are around 100,000 people globally with sales revenue closing in on 50 billion and a couple 100,000 units being produced. So one of the 3 leading, you could argue, global OEMs for trucks and buses. That should suffice for the time being as an introduction. Let's get into why we are discussing and how we are discussing BEV range today on the next slide. On the left-hand side, you see basically a typical view that we've heard in the last couple of years, time and again. This is just one quote. We could have brought any other quote in there. They don't differ too much. Numbers change a bit over time. But basically what they've been saying is that BEV in line haul operations, in true long distance operations for heavy duty trucks, doesn't really work all that well. Here the example is going 375 miles a day and basically losing almost all of the payload, just retaining around 10,000 pounds of cargo. And of course, charging times being absurdly long, could even argue 12 hours. Many other publications claim at least a couple of hours. So this doesn't make sense. This is not a line haul product. But in the near future doesn't mean 2030s. We're looking more at something like on the right-hand side, where we're not talking about 375 miles, but 750-ish with a catch in a second. There's still a lot of weight in that battery, to be fair. There's still some payload loss, but this now looks entirely different, like maybe 5,000 pounds or so. And that is coming down over time as batteries develop and as fuel consumption keeps coming down. So the base idea here to bring us from 375 to around 750 is to go with a top up during the mandatory rest period. Driving a truck for a full day, maximum of 11 hours, you have to have at least 30 minutes of rest period in between. And this is what can be used with the upcoming, Sharon has been mentioned, megawatt charging system standard, where we can get to around 80% in around 30 minutes or so without significant tear and wear on the battery. So this is important to state, because just because the battery is larger doesn't mean it has to charge more slowly. It's basically happening in parallel for all the different packs in that battery. So 30 minutes is not harder to achieve than it would be on the passenger car side too. And this is just basically the first generation product for a line haul battery electric vehicle. And suddenly we're talking about something where there is, with one in-between charging break with infrastructure, basically a full day range easily possible, where there is some payload loss, but not too much anymore, and where the charging can be done within the typical driver's rest period. If we do go on to the next slide, this shows a bit of why this really matters, because it's nice to be able to say we can do line haul with battery electric vehicles even in the next couple of years. This is the reason why we would want to do this. On the left-hand side, you see the cost distribution of a typical line haul heavy-duty truck as it is today from a diesel perspective. And not surprisingly, this is well utilized. Intensive usage means that energy, including every cost coming on top, especially the diesel cost, of course, is going to be dominant. And it's going to be more dominant than in any other truck or car for that matter application. This also means if you find a way to reduce energy costs drastically, this can be quite a good business case. And that's exactly where battery electric vehicles come in a way that diesel can't, that hydrogen, that no other solution can. Because energy is significantly cheaper when it's being provided via electricity due to the high efficiency of using that. And again, fuel cost is absurdly dominant. You see the vehicle cost in comparison here being significantly lower. Of course, it would be higher than it is on the diesel side for a battery electric vehicle, but it's more than made up for the savings on the electricity side and some savings on the R&M perspective. So basically another way to think about it, this is if there was a potential out there to get a truck down to diesel and just paying maybe $1.50 or $2 per gallon for that diesel fuel, this is definitely something that would be highly competitive, even if that truck was more expensive to begin with. So the savings potential is crucial, is significant, and energy cost is by far the most important driver in here, especially, and this is important, especially in line haul operations, making this the best BEV business case. And what it takes to get there is fast charging infrastructure, not absurdly fast charging infrastructure, yes, based on the megawatt charging system, but not up to the maximum limit that it could theoretically provide. And once we have that, basically today's batteries are good enough. They've already brought us to where we need to be. Every additional advancement, of course, is nice to have, but we don't need anything fancy coming on top, just those chargers. And basically then we are without meaningful payload or charging time losses. And importantly, basically we are cheating. We're halving the battery size and we still get the full energy cost advantage. And this is very hard for diesel to compete with from an economical perspective. Going on one more slide. This is a bit of a deep dive of how this changes if you look at different distances and also over time, over the next couple of years. First of all, left-hand side, the energy efficiency, of course, is key behind this. This is why battery electric vehicles will be cheaper than diesel or any other truck, even without subsidies over time, and especially in line haul operations. Again, highest hanging fruit, but also probably the shiniest. And especially if we're talking regular long distance usage, where the battery can be amortized most easily because every time you're using it for the fullest, and where, and this is super important, the margin pressure is especially high. Because what this means is there's typically a margin of maybe 3 percentage points or so in that business. And even if many players might not want to go to a battery electric vehicle, might want to go for diesel or hydrogen or something else, if those who can make this work are actually a bit cheaper or significantly cheaper or massively cheaper as shown before, then they will exert margin pressure on anyone else. And then, of course, payload, range, charging times, all of these keep improving, even where we are right now with those first generation products, where it's more than good enough, you could argue. It will keep getting better and better. And then especially talking about the future, when we are talking about, of course, more expensive products being used more intensively too, especially when it comes to autonomous driving, which means the energy cost dominance is even more pronounced. The driver, of course, there's no driver in that scenario. So we are talking about a future where the business case from a BEV perspective is significantly stronger still than it is even today. And then there are two other effects that are important to keep in mind, because the system perspective is always super crucial to adhere to. One is, when are we charging? It's mostly during the night times when there's little demand for electricity, and for these top-ups, during the midday solar peaks, where we are seeing more and more instances where the grid is actually struggling to try to disperse, to try to get rid of all that electricity being generated. And having a well-distributed set of sinks, trucks charging, geographically distributed, that can actually help reduce pressure on that grid. At the very least, it typically doesn't increase pressure on the grid as much as it's sometimes made out to be, which means the infrastructure is cheaper to build out and the energy, of course, gets cheaper too. And then second point, importantly, even if we had, for example, ample cheap hydrogen or any other fuel out there, you could reconvert, of course, that fuel into electricity. And you would do this during the spikes in electricity, which means you can really optimize when to do so. Instead of using it directly in a truck, you would use it outside of a truck and have a much better cost position in doing that. Which all of this coming together means line haul may not be the first because the infrastructure has to be there, but it will be the most profitable battery electric vehicle use case, and leaving the least room for other solutions because this is a high margin pressure business. So this margin pressure, that will be important. And it will be enough if some players out there can make this work, if there are some corridors that prove the case is there, and the rest will have to join in, because otherwise, from a margin pressure perspective, they will not be competitive enough. And this means, going to the next slide, from our perspective, and to the last slide, to be fair, our focus is quite clear. We see battery electric vehicles as our mainstream technology for the future, and importantly, not just including in line haul, but also especially in line haul. Again, because of that high energy cost dominance, because of the high efficiency of running on electricity, and because of the margin pressure in that business. So I think I'm at the end of my time too. So I would also hand over, and I'm looking forward to our panel discussions.
All right, thank you. Thanks for having us on here as well. So who is Hyliion? Let's start there. We're a little bit of a lesser known entity than some of the folks on this panel. Our mission as a startup is to be the leading provider of electrified solutions for the commercial vehicle industry. And really the focus for our company at the moment is in electric range extender technology, and we'll talk about that a little bit here shortly. But just going through kind of our focus as a company, we are really focused on reducing that carbon emissions footprint of our customers. And we also want to do that in a way that reduces the cost of operations, because you really can't have a viable solution at scale without it making economic sense. And then another thing that we really focus on is leveraging existing infrastructure as much as possible. We view the infrastructure question as one of, if not the largest barrier to adoption for electrified technology in the next 10 years or so. And so we'll kind of talk about the rationale there. We have about 250 employees or more. We are publicly traded under HYLN. We have 3 offices. I'm calling in here from Cedar Park, Texas, but we also have a facility in Cincinnati and Pittsburgh as well. If you'll go to the next slide, please. So like I said, one of our focuses right now is in electric range extender technology, because, like a lot of the other panelists here, I think we've identified that BEVs, traditional BEVs, are excellent for certain applications today and maybe even into the near term. There's a lot of great products out there. However, they have pretty significant range limitations as they are configured today. That could change over time as battery technology advances. But right now, you're kind of tethered to that infrastructure challenge. And so that's where we think electric range extenders come in. And so we'll talk a little bit here about our product, which is kind of an example of one of those, Hypertruck ERX. But in general, the basic concept is that you're bringing your power source with you and charging on the go and utilizing the type of infrastructure that is much more prevalent and more easily deployed than the megawatt standard, for example, that we've been talking about. We think that technology will start with renewable natural gas, which is available now and has a great footprint from an environmental perspective and is quite cheap. Hydrogen, should it become more cost efficient and greener in the future, that's where that segment could head in the near future. If you'll go to the next slide, please. So just quickly before we go into things, what is a Hypertruck ERX? So in technical terms, it's a series hybrid. So in more kind of layman terms, think of it as a shorter range battery electric vehicle with a range extender on board. So this is a high-level view. We'll go into a more detailed view later on. But in essence, we're taking a natural gas engine, turning it into a generator, and utilizing the associated infrastructure with that. Now, what that allows us to do is to provide an electrified solution that has, compared to the competition today, a much longer range, while still providing a fully electric operation mode for areas that need that today. And using RNG, it can be quite compelling. We'll talk about that shortly. If you'll go to the next slide, please. So with Hypertruck ERX, we really unlock applications that today aren't able to be serviced by battery electric vehicles, primarily long haul. And that's through our ability to deliver up to 1,000 miles of range with our powertrain. But at the same time, we also provide the performance that's necessary for that application. And there is an electric APU integrated into our system. So we're launching on a sleeper platform. And so that really is well suited to that. Now, regional is also another application that even in longer distance regional applications, battery electric, it does struggle today. And so in that sense, we are well suited as well, and can provide up to 75 miles of all electric range in that type of application. We can be charged through a plug-in, so we'll talk about that, but the system can go and be operated without ever having to be plugged into any charging infrastructure. For the driver, though, it does provide a significantly improved experience that we're all at this point very familiar with from electric powertrains. They're smooth, they're much quieter, and they give the driver a greater sense of confidence because of their performance. And so that's a huge benefit as well. If you go to the next slide, please. So let's dive a little bit into the technical details. What does this actually mean in practice? Because this is a unique solution in the industry. So if you look at the slide, we're actually going to go right to left, so front of the truck to the back. Starts with the generator. So we take a CNG engine, internal combustion engine, we pair that with an electric motor, and that turns into a generator. That generator is not mechanically linked to the wheels at all. It is simply serving as a generator. Beyond that, we provide an HMI interface to the driver, the co-pilot you see there called out. But to allow for that fully electric capability when the generator is off, we do install high voltage e-accessories like the HVAC, the power steering, the heater, the service air compressor are all high voltage and can operate with that generator off. From there, we actually, like I mentioned, we do have a plug-in charger. It is a CCS1 DC fast charge capable. So, some of the fleets in the future will have that infrastructure, and the system can take advantage of that, much like, we talked about in the last presentation, for short periods of time. Opportunistic charging is what we call it. So that's there. That also provides certain regulatory benefits as well. Moving back, we get to our thermal management system. So we have two different loops within the powertrain, one for the batteries, one for the actual axles and the rest of the powertrain. And then moving back from there, we have our batteries, which are about 210 kilowatt hours. Those batteries, again, can serve as a storage for energy to be used in the future, either through an all-electric mode or through an extended electric APU period, or they can be used to power the axles. Moving back from there, we have our computing hardware, primarily the HCU and the HTP, and then, like many trucks, we have dual e-axles. So if you go to the next slide. For us, it's really predicated on infrastructure. So, we think, and from what we've heard from other, OEMs in the space, we're not an OEM, we're a powertrain, supplier, but from what we hear from OEMs as well as fleets, that, the challenge is really not in buying the electric trucks, it's in installing the infrastructure and working through all the hurdles with local utilities. So we're looking to solve that by utilizing the existing CNG infrastructure, at least to start. And CNG, I think in this broader discussion that we're having as an industry, is overlooked, and I think that's reason because of bad experiences in the past. But I think a lot of that has changed. And RNG, which is essentially the same molecule, it's just kind of a digital ledger transaction, has really strong emissions benefits. In fact, more so than hydrogen BEV in pretty much all parts of the country. It also is very cheap. And that's something that can't be said for grid electricity at times, peak charging we talked about, as well as hydrogen. So it's very affordable. It makes for a positive TCO. And in certain regions of the country, you can support long haul or over 500-mile routes with the infrastructure in place today. And then for those of you that are familiar with CNG versus diesel, you can basically operate these trucks, assuming you're around those stations, in much the same way as the diesel today. So if you go to the next slide. I wanted to end with kind of where we're heading because, for us, we are focused on range extender, onboard range extender technology. And really what that's focusing on is what's generating our energy. So today we're using that, as I mentioned, CNG engine paired with an electric motor. Where we're heading in the future, though, is Carno. And this is a technology we're extremely excited about. We had acquired this from GE Additive last year. It is a really fascinating technology. It's basically a heat-driven sealed linear generator. So the unit takes a fuel. It can burn up to 22 different types of fuel at this point. It takes that fuel, converts it into heat. The heat itself is what drives the generator. So it's a very simplistic concept, but that is very difficult to execute in practice. And we're actually rolling that out today at our investor conference and a stationary application as well, which we think will help mitigate some of the infrastructure challenges that the industry is facing. And we can go into that in more depth in a future discussion. But in general, Carno, the benefits that it provides is that fuel flexibility, greater efficiency, as well as reduced emissions, and we expect reduced maintenance as well, because in each of the shafts of the system, there's only one moving part. So wanted to end with that. Really appreciate the time to come talk about our technology. And with that, I'll pass it on to John.
Yeah, thanks, Jason. Next slide, please. Yeah, I'm John Cressy. I'm with Cummins Corporate Research and Technology, and I'm going to talk about wireless inductive charging. You've heard a little bit about it through Andrew, but a couple examples for you. Next slide, please. Yeah, so the Cummins is working on a number of low carbon technologies. Those not related to internal combustion engines are primarily developed and sold by our Accelera brand, electrolyzers for green hydrogen, and then you'll see all these other ones. I'll try to speed things up so we have time for questions. One thing is our sales and service organization and our distributors, they do sell direct to fleets EV charging solutions. So I wanted to highlight that. Next slide, please. All right, diesel powertrain development, primarily a power management problem. We don't worry about energy, the energy density of diesel. It's fantastic. 200 gallons of diesel, you can drive halfway across the country. As we move to commercial BEV, now it becomes an energy management problem. As you've heard from the panelists today, you have to worry about sizing your battery for your duty cycle, and you have to worry where you're going to get your charge for the day. There's a couple ways of doing this. You can either size your battery for your full work day, and that could get expensive, and that could prevent you from doing the things you normally do with a diesel truck. So that first example there with the truck showing the 3 little batteries, so that truck's been sized and it's only using depot charging. If you're able to use opportunity charging during the day, that truck with a smaller battery could be cheaper, could do a lot more work, and ultimately could do the same things that some of your higher energy diesel trucks do today. In this cartoon, you'll see those opportunity charge are provided by wireless charging. This could be provided also by plug-in. In some instances, wireless charging has some advantages. The driver can stay in the truck. At times, the conductive charging or wired charging, the cable management with all the cables around several trucks or buses can be problematic. And so there are certainly advantages to wireless charging. And yeah, let's see a couple examples. Next slide, please. I'm going to get into a couple examples where stationary wireless charging has helped. So this slide's courtesy of our friends at Antelope Valley Transit Authority, located in Lancaster, California. Several years ago, they decided they wanted to go all electric. And as they started to do that, they realized they were going to need a lot more buses than diesels. And so they worked with Wireless Advanced Vehicle Electrification, the manufacturer of wireless charging systems, to figure out how they could get back to the one-to-one diesel to battery electric bus replacement. The wireless charging provides an advantage for the bus stops here, where the driver obviously is not going to want to get out and plug in. You don't want cables around where there's passengers. In this case, the buses already have to stop for 5 to 15 minutes to synchronize their routes. So it was appropriate time to stop. 10 minutes on the 250 kilowatt wireless chargers they have today. That gives them about 10 to 13 miles of additional range. We can go on to the next slide, please. So this is what they've ended up doing. They have probably about 65 buses, pretty big valley, the Antelope Valley in northern LA County. They have pretty high energy requirements because of the routes and also because of the high air conditioning load on the buses. And you'll see here that they have a little over a dozen wireless charging systems spread throughout the valley to do what they need to do. And you know, as the slide says, as of about a year and a half ago, they became the first all-electric transit agency in North America, even though they have some pretty high energy routes and they want to run these buses 16 to 20 hours a day, and they want to so they do use low power charging in the depot overnight for those buses that do go back to the depot. So next slide, please. I'm going to give you another example. So this is a project I lead, and this is where we're using 500 kilowatt wireless charging for the drayage or factory logistics application. So this is Class 8 day cab. Our target duty cycle is shown on the left. The fleet operator wants to run 20 hours a day, and the routes are relatively short. And our goal here was to have a small battery on our Class 8 truck, but we still want to run 20 hours a day. And in this case, we were targeting 3 to 4 fast charges, as you see in green here. The target duty cycle also includes, in this case, bridge grades. So even though the routes are relatively short, the energy is pretty high. On the right are the partners on this, and it includes Venture Logistics, who is a fleet operator delivering to the Subaru factory in Lafayette, Indiana. So instead of doing drayage, we're doing factory logistics, but it's a very similar route. They want to run the trucks 20 hours a day. And you'll see the vehicle metrics. This is typical Class 8, pretty short range, but again, if we can use high power wireless charging several times a day, we can meet the meet the 160 to 200 miles that the workday vehicle range will be. So why don't we go to the next slide and we'll take a look at what we've come up with. So there's our built 2 trucks, Class 8 BEV. You'll notice the battery's pretty small, 212 kilowatt hours. But again, with the appropriate high power wireless charging, that can even a small battery vehicle like this can do quite a bit of work. The charging system is shown on the right. In wireless charging lingo, primary pad means the pad that's providing the power, and in this case, and in the road. So the primary pad, those pads will be installed, and the secondary pad is the on-vehicle pad. And again, we're going to deploy this to Venture Logistics in Lafayette, Indiana, to deliver to the Subaru factory in about 2 months. We can go on to the last slide, I think. Yeah, so I wanted to leave you with this. It sounds a little bit like science fiction, but the same kind of technology used for stationary wireless charging can also be used for what we would call dynamic wireless power transfer. Some of that power that is being transferred could be used to charge the battery, but much of the power would go directly into powering the electric machines for your traction system, and also supplying power for your accessories and your thermal management systems. So instead of calling it dynamic wireless power charging, we call it power transfer. This is one of several projects. There's probably more than a dozen of these projects throughout the world right now in various levels of deployment. And in this case, Indiana Department of Transportation is funding this development just west of the Purdue campus, and Purdue is developing much of the wireless charging system. This system is interesting in that it's scalable. A truck can run over it and receive 200 kilowatts of power, which is enough to keep the truck running at 60 miles an hour and provide some charging. And a car could run over the same with a smaller secondary pad or receiver plate, and it can receive 20 to 40 kilowatts of power. So that these systems could have quite high utilization if we combine trucks and we combine passenger cars. Certainly a lot of challenges. When people first see this, they think of there's a lot of opportunities, we'll say, but there are a number of researchers around the world working to solve these, and it's possible that this becomes, at least in localized areas, this becomes a technology that you'll see in the next decade or so. All right, that's next slide is just my contact information. We can start the questions.
Yeah, thank you, John. If I can have the panelists turn their cameras back on. The feedback from all of you seems to be that you can design a truck with an appropriate battery pack, but the more complicated part of that seems to be how to get the energy into the truck. And so you've all provided feedback on different mechanisms for that. How does that variability affect, in your opinion, how does it affect the choices that fleets will have to make? Are they buying into a technology for a decade before they can move on to something else, or are they going to be able to adapt the technology over time? Andreas, how about an answer for that?
Yeah, maybe to get this started, this is one of the, let's say, nice side conditions of a prime path that is focused on BEVs. It's just going to get better. You will have more infrastructure coming in over time. It may take more time, it may take less time, but there will be fast charging. We know the megawatt charging standard is out soon. I've seen there was a question on this. We may not need to go to the full 3.75 megawatts anytime soon. Something slightly above 1 megawatt may in many cases be sufficient. But of course, over time, this could expand if there's a business case for it. For us, the most important thing is always, what about the business case? And trucking, especially long distance trucking, keeps being dominated by energy cost. And this is something where diesel, gas, hydrogen, all of this is not going to be competitive in the long run because of inherent inefficiencies. So the long-term picture, 2035 plus, is even clearer, I would argue, than the path to get there, which is going to be full of political pitfalls, subsidies, false friends, and so on. Long-term, we are talking about highest efficiency, lowest cost being the prime path, and that would, from our perspective, clearly be battery electric vehicles. And then battery technology is, of course, going to get better. So second generation truck is going to be better. So you would not necessarily keep on using the same truck for decades onwards, but the same technology.
So John and Andrew, as far as the wireless charging is concerned, you have to install things on the truck to enable that. Is that technology going to be able to evolve so that a truck bought tomorrow can operate on a system in 5 years or 10 years time?
Yeah, that's a good question. Right now, there are some challenges to stationary wireless charging. Interoperability between manufacturers of systems is a challenge, and as well as cost and weight. Those challenges are being looked at right now. I think the end game is, yeah, we'll have interoperable standard, and they'll be lighter and less expensive. But those definitely challenges right now in that area.
Andrew, do you have any thoughts on that?
And I agree with what John's saying. And I think the other part that I add is, typically when we talk to fleets and folks installing these things in, say, like a bus garage or another depot, try and plan for the future. Like if you're laying new line within your terminal, maybe make considerations for putting in a wider trench than you are going to use now, things that might be able to be easily removed, and sort of try and understand what the future pathway is for it. Because a lot of times, the technology isn't there to electrify everything today. So trying to plan for those types of things is important.
Great. Jason, we had a question on CNG. So in the system, the hybrid system with a small CNG motor driving a generator, how is that what are the positive benefits of that versus just having a larger CNG engine running on RNG?
I think that's a great question. I think a lot of it comes down to the fact that you can deploy that vehicle without that engine on and still have it complete its mission, right? And so, we're here in North America a little bit behind where Europe is in zero emission zones, but that is coming. And certainly if it's not zero tailpipe emissions, it's also zero noise emissions, right? No one wants their truck running by their house at 12 o'clock at night. They're loud. So that's one of the benefits, right? Is that you provide the fleet operator the ability to operate a truck in a fully electric, kind of BEV-esque mode without some of the limitations, right? Because right now, does that mode have to be applied, for the entire route? Perhaps not. And a traditional CNG engine doesn't have that ability. The other part of it that we're focused on is, we view this as a platform as much as it is a powertrain. And as such, because it's electric, we can update that over time. You can't really do that with a traditional engine. You're kind of stuck with the hardware and tuning that you purchase that vehicle with. As we've seen with, Tesla and Polestar in the passenger car space, you can have a vehicle that, evolves over time. And that's kind of where we're headed. Beyond that, it does provide the ability to utilize that electric propulsion system, which, from our discussions with drivers is much preferred over a traditional internal combustion engine, CNG engines included.
Great. Andrew, you've been doing testing in parts of the world that get cold. What's the impact of weather on your projections for battery size and charging needs?
Yeah, that's a big question. The best data that we have has been in transit buses, which I would argue is probably the most challenging case just because of the large cabin size and the need to maintain passenger comfort. We've seen for instance, in Zion National Park, 40-foot bus having about 25% of its energy going to cooling the bus in some of the hotter temperatures. In Duluth, Minnesota, we've actually seen the fleets adopt fuel fire heaters on their electric buses because the battery electric system isn't able to keep up in some of the minus 20 Fahrenheit cases. So it's definitely a challenge. I think that trying to identify some of these other maybe cool weather technologies or other sort of thermal efficiency improvements in terms of window glass glazings and things like that, maybe options for reducing the impact of the HVAC system.
Great. Andreas, in terms of, you were talking about a 750-mile range for a truck with a 30-minute mid-route charge. What sort of battery pack are you looking at for that kind of application?
Well, it depends a bit what we assume where fuel consumption is going to be. And to Andrew's point, there's also going to be a bit of variability depending on topography, climate, etc. You always want to have buffers. You will design your battery to be able to cater to maybe not the worst day. Maybe there are some days where we'll need to have a second recharge event, but most days should be fine with just one stop in between, just to give an example. And then we are talking something that is probably a bit less than a megawatt hour, which is somewhere in the sweet spot where with battery technology, as we see where it is right now, both from a cell and from a pack perspective, we have a plausible path to something that is close to payload parity on a line haul truck for a battery electric vehicle over time. And that is then ideal, because then you still have the energy cost advantage that I've been talking about so much, but you have a battery that is reasonable in terms of weight, in terms of packaging, don't have a volume problem with that coming in, and that can withstand the kind of charging power that we would require, maybe a bit more than a megawatt.
Okay. I constantly get questions on swappable batteries. The first trucks that came out in 2010 were proposed to have swappable batteries. It's an idea that keeps coming up. What's your thoughts on that? Anybody want to take that?
Sure, I'd be happy to take that. So I think that the other challenge with that is that you're investing in more batteries, which tend to be expensive. Putting in infrastructure to do the swapping, and there are applications of it. We've seen one in the Port of LA and Long Beach where they have some of these what kind of look like skateboards that drop down, but that's a very sort of custom solution. So I think that it's one of those things that I think cost is really a driving factor as opposed to the technology to actually swap the batteries. But we do see some passenger cars doing that.
Okay. Well, thank you. I'm going to turn this back over to Rachel to finish it up.
Awesome. Well, thank you so much, everyone, for this fantastic conversation. And thank you for everyone who joined us today. That is going to wrap up our 5th bootcamp session. Remember to return back to the landing page of the session on runonless.com to take the quiz. It is now available. And make sure to connect with us on social media. We have all of our handles linked out here. Thanks again. We'll see you on the next session on July 11th, where Ari Khan and his team they're going to be discussing the electricity resiliency and availability for these technologies and for this depot. So thank you so much again, everyone, and we look forward to seeing you in the next one.